So for number 6, this was already isolated. So as you start solving it, less than is an and. Make sure you set it up both ways. Whatever it is stays the same, and then the opposite, change the sign, change the number to a negative. It's not showing every single step, but add 1 to both sides, multiply by 2 to both sides, or divide by 1/2, either or. Because this is an and, this would be from -2 to 6, or -2 is less than or equal to x, which is less than or equal to 6. Both with closed circles, both with square brackets. Do we have any questions on that one? Are we good on that one? Anyone still need that one? Number 10. Again, some of this work is not shown, but divide both sides by -8. When you do that, your sign changes direction. So this was an or, but now it's an and. After you have isolated your absolute value sign, set both of them equal. I'm sorry, not equal, but change the sign of one, make one negative. Keep solving, so subtract 1 on both sides. Here you would need to multiply on both sides by 3. And because this is an and, you would write your inequality answer. -6 is less than x, which is less than 0. You would have open circles, the interval notation is not there. These would be parentheses, -6, 0. Did you get that one? Yes, I see some yeses. Did we have questions about that one? Yes.
So if we like divided by a negative number, we'll always count.
Whatever the sign is will change, yes.
Okay.
So if it was an and, it'll become an or, and vice versa, yes.
Okay.
So that may be confusing if you're just writing it out at the beginning. Like at the beginning, you probably wrote this as an or, but when you divide, you have to change it. It's whatever it is when this is isolated or by itself. Other questions on 10? On 12. Here, I saw some of you dividing by 4 first, but you should have subtracted 1 first. Get rid of that first. Otherwise, you end up with fractions, decimals. We want to avoid that. So subtract 1 on both sides, then divide everything by 4. Then from there, this is an or. So keep this one the same. Make this one less than or equal to with your negative. Add 8 on both sides. And you get x is less than or equal to 7, or x is greater than or equal to 9. These should be closed circles going away from each other. And then square brackets at the numbers. Anyone have questions on that one, Peyton?
Does it matter like which order you have the like x is less than or equal to or no?
So I said before that it didn't matter if you want to put it least to greatest, then that would be better.
So on the test it won't.
No, because I didn't, when I originally wrote it, I don't think I wrote it as it mattered. So it won't matter on the test now.
But on the test for the and one, we have to put like the equation with the and.
So you would need to put it in the inequality format.
And whenever and
Yeah, so for the show your work questions, there'll be a place for both of those. Some of them will be multiple choice, so you won't need both of those. Yeah.
How are we gonna like put it on the end? Do we have to tell all the staff to be on
Just like a normal test. Other questions on 12? Kayla, did you have a question?
No, I'm just gonna wait to see what the answer is.
For 14?
Yeah.
Okay. Alright, 14. Now this one was a little tricky because it had the 16 out in front. Usually it's back here. But it's doing the same thing. So you need to get rid of that 16 first by adding it to the other side. Then get rid of -3 by dividing. Again, that's not shown, but that's what it should be. After that,
-16?
say that again.
Do we have -16 or 16?
No, just add 16. Divide by -3. That changes your direction of your sign. So it was an or, now it's an and. And then here, this is isolated, so this should stay the same. And then greater than or equal to -11. Add 5 on both sides. Divide everything by 2.
I didn't change the sign, but I still and grab it.
That may have just happened to work. Try not to do that in the future.
How are you gonna do
The -3 is less than or equal to x, which is less than or equal to 8. And then this should be from -3 to 8 in square brackets. Do we have any questions on that one? We good with that one? Yeah. Take out your graphing inequality notes. Does everyone have their calculator? If not, go grab it. I'm going to show you how you can check yourself on your calculator.
That's not cool at all.
Does anyone need another copy of these notes? Reset your calculator, second plus 712.
Did you see the calculator?
Yes. And this will be second plus 712.
That's how you
That is how you reset the entire thing.
I was really sad.
I really wanted those on my brain. I used a lot better.
I agree.
Do you just leave it?
Keep them both like some basic important information.
Say that again.
Do you just leave it like after everything?
Yeah. That is said the next steps. Okay. So I talked about last class how you could check yourself in Desmos. I'm waiting on everyone's voices to Stop talking. Here is a way you can check yourself in the calculator. If you go into apps, so right next to math, APPS, apps, yours will only have 4, or should only have 4, mine will have a whole bunch. So when you're in apps, you're looking for inequals, INEQUALZ. Does anyone not have that app? Because I think I fixed them yesterday when we did this. So when you find inequals, press enter. Your calculator will do this. Okay. We are going to go back into, or go into what equals. I could get you one, Taylor. No, we have some. We have extras in the math program if you need one. Okay. So go into your y equals. When you do that, I'm going to make this one whole calculator. And you hover over your equal sign. All of these options at the bottom pop up. So if you want to change your inequality symbol, we need to use alpha and then whichever symbol we want. So if we're doing number 2, on your notes, y is less than or equal to negative 2x minus 1. We need less than or equal to, which is above zoom. So alpha zoom, and it will change it.
I don't have that thing.
Alpha.
I don't have that.
Did you go into apps?
I press apps.
Ooh. So if you didn't go into apps and equals, you wouldn't have that.
Sure.
So, if you needed to change it, you could just alpha whichever one you need. And it'll do that for you. What's nice about this is when you change it, this kind of tells you whether it's going to be a solid or a dashed line. So if I did alpha window, this tells me it's going to be a dotted or dashed line. This one tells me it's going to be a solid line. This also tells me it's going to be shaded below. Back. What equals? Same thing for the other ones. It'll also tell you it's shaded above. So after you have that change, go out of that and put the rest of this in. Negative 2x minus 1. Press the right button. I'm not letting you press what? So once you have this in your y equals, hit graph. This will graph it for you. You could count your y-intercept and slope from here. It'll show you whether it's dashed or solid, as well as whether it's shaded above or below. So that's another way to check yourself. The only bad thing about the calculator is that in the inequalities or inequals app, you cannot use fractions. So like if I go back to my y equals, and let's say I wanted 1/2, I would need to put this in parentheses as in parentheses 1/2, and then x, and then whatever, in order to graph it. Because if I hit just 1/2 or try to hit 1/2, it won't do it. It'll change it back to equals. But to get that back, to get your alpha y equals back so you can actually do fractions, go back into apps. So everyone do this. Go back into apps and then I'll answer your question. Go back into your inequals. Hit enter and you'll get a menu that looks like this.
Wait, what did you do?
Go to apps, go back into inequals.
How do I do this?
Press X, go into inequals. Say that again. I mean, I do it a lot. If you quit the inequality graphing, then you can do alpha y equals and get your fraction back. Okay. CK, you had a question. Then there were other questions.
Didn't let me finish. We're supposed to do this.
Sound the same as a minus instead of a negative.
I don't know what.
I've never used
Priscilla, did you have a question? Alright, so now we only did one problem last class, right? Yes. We're going to do 3 and then you'll have time to practice some others. Yes.
We have to use the calculator.
No.
I feel like it's easier just to do it on paper.
Yeah.
We answered all of these, yes. We didn't know. No, and we didn't do 2.
But we did number 1.
Yeah, we did number 1.
Yeah.
Go to the back. Let's do number 3. Yes.
Oh, number 2 is supposed to be a dash line or?
It means you put it in as a dash line. You put less than instead of less than or equal to. Okay. So for number 3, can we graph this as if? No. We have to make it slope-intercept form. So what do we need to do that? Subtract 5x on both sides. Negative 2y is now greater than negative 5x plus 12. Divide everything by negative 2. So our inequality is now y is less than positive 5 over 2x minus 6. Theo, after this problem, yes. Right. So we would have a y-intercept at negative 6. Our slope would be 5 over 2, so go up 5. To the right 2, as many times as possible. Would this be a dashed or a solid line? Dash. Shaded above or below? Less than is below. Do we need a dashed line? That should definitely have arrows.
So less than is below and greater than below.
Correct. How do we know if it's dashed? If this doesn't have an equal to or not.
So a closed circle plus line.
Sure. You can say read it like that.
That is not what in the world.
Wait, so you're trying to
For your slope.
It's
okay, then the negative 6 is. What is my
Your y-intercept.
my one?
So when you have certain slants, it may be hard to see, is this, where is above, where is below. So look at your y-intercept, draw an up and down arrow. Up would be above, down would be below. So wherever the down arrow is, that's where your below would be. And this would be the area you shape.
Wait, how do you determine it?
At your y-intercept, draw an up and a down arrow. We already know it's supposed to be below, so down will be below, and then you shade where the down arrow is. Because just looking at it, you may not be able to see which side is below or above. Sometimes it's easier to tell than others.
I think so. Only kind of academy.
Negative 3/4 for the solution. Negative 3/4. Oh, no.
2 and -3.
2, -3. That one would work. Doesn't have to be that one. You can pick whichever solution you want. Just make sure it falls within the shaded area.
This one.
Yes.
What's the equation we did yesterday where one of the points was like on the line?
Oh, give me 1 second. We'll do that.
So if it's on the line, is it a solution?
For this one, it would not be. So let's say I took this one right here. What's this? 1, -2. You're going to take either the equation you have or your slope-intercept form, inequality, not equation. Doesn't matter. You're going to put that point into your x and your y. So let's say I put it in here. 1, that's 2. Thank you. 2, -1. There we go. So 5 times 2 minus 2 times -1 is greater than 12. So 10 plus 2 is greater than 12. Is 12 greater than 12? No.
Since we already like knew the answer because the line is not like movable, do we really have to do it again? Because we knew the answer, that's
Right, so I would say if you know for a fact that you're going to avoid points on the line, if it's dashed, because it won't be a solution, then no. But if you're not sure, then do that.
yeah. Because if it was like all lined up, that includes when we correct. If it's not down, we all
Other questions on that one? Let's do number 5. So we again need to make this in slope-intercept form. Subtract x on both sides. So we have negative y is greater than or equal to negative x plus 8.
But that's the not What?
And then divide everything by -1.
So the sign will be
The sign would be flipped. Y is now less than or equal to x minus 8. So this is a 7 by 7. So just go right here. You can't see that. So our slope would be 1 over 1. That would be up 1 over 1, up 1 over 1, up 1 over 1, and would this be dashed or solid? Solid. If this was dashed, because these are so close together, I wouldn't want to put little dashes in between them. You can just make this a dotted line and draw arrows at the end.
Oh, dashes.
Would this be shaded above or below? So from here at my y-intercept, if I draw up and down arrow, below would be this area. Someone give me a point that would be a solution. Bella. 5, 7. 5, 7.
-7.
Negative 7 would work.
And also,
Wait, this
Negative
square
Hold on. Need to finish your thought process.
4 and -4 would also work.
There's a lot that would work. Yes. Ask your question.
bracket.
These are just ordered pairs, so just parentheses.
7, -7.
That would have also worked.
It has to be in the shading area?
Has to be in the shading area, yes. That's 4, -5. 4, -5 would work. What's this? Oh, so in general, we're graphing this on a tiny 7 by 7 graph. In reality, this graph would go off the page towards infinity forever and ever because domain and range would keep going. So in reality, if we're thinking off of this piece of paper, we could pick anything in the shaded area that would work. So I could say 100, -7. That would work. Somewhere way off the graph, that would still work. Now, when we write our solutions, they should be somewhere within the graph. But just know that as well. Next, questions on 5? Yes, I'm going to also be for this one, yes, and you could check it. So really quickly, if I did like this point, 7, -1, and I put these in, 7 minus -1 is greater than or equal to 8. 7 plus 1, not 8, is greater than or equal to 8. 8 is greater than or equal to 8. That is a true statement. That would work.
So whenever it's like greater than or equal to the point, will be
Equal to. Greater than or equal to, less than or equal to, it will be a point, yeah. Okay. Jump down to number 8. For number 8, these are just x and y, so these will not be diagonal lines. They'll be straight, horizontal, or vertical. For 8, would it be horizontal or vertical?
Horizontal.
vertical.
Vertical. If you need to write your point of X, do that. So this would be a vertical line at 6. Would this be dashed or solid? Dash.
Maybe I should look up.
We're going to talk about that in 1 second. So for, it is going to be above, but since this is really more of a left or right, we have to think about these numbers. So if I pick something over here, like 0, is 0 greater than 6? No. No. So that means I have to shade in this direction. Because 7 would be greater than 6.
Wait, so it's up and down because the x is
Because the x is vertical, that's why it's up and down. And then you're looking left and right. So greater than is right, less than is left. Yeah, it would keep going towards infinity.
And the point needs to be open.
Ask that one more time.
The point needs to be open.
No, not, well, this would be an open point because it's not included. I just drew it like that because of the line.
Okay.
Oh, okay.
It'd be a dash line. Okay. Someone give me a point that would be a solution, and Lily, what was your question?
never mind.
Are you sure?
Yeah.
Okay, thanks.
Number 7, like would the -4 be on the y-axis or the x-axis?
Y-axis because he has a Y.
just like this one was on the x-axis. Yeah.
7-0.
7-0 would be a point. And in reality, if we're thinking off the graph, 7 negative 1,000 would be a point. 1,000 would be a point because eventually it's going to keep going that way. Right. Do we have any other questions on 8? I'm going to give you 5 to 10 minutes to work through the remaining 4 problems. So number 2, number 4, number 6, and then 7. Then we'll come back and we'll talk about it. Starting at number 2. This was a solid line shaded below. Cool.
Oh, no.
The only ones that were solutions were 0, -1, and -4, 0. Do you have any questions on that one? On the back, number 4. Your inequality was y is greater than 1/4 x minus 2. So that was a dashed line shaded above. I picked 0, 0. You didn't need to pick the same one as me. As long as it fell in the shaded area, then that works. But if it fell on the line, that would not work. Questions on that one? Jenna?
It's a solid line, it wouldn't fall on the line, right?
Yes.
Okay.
Number 6. Your inequality was y is less than -3/2 x. So this was a dashed line shaded below. The point I chose was -2, 0, but any point in here would be a solution as long as it didn't fall on the line. Questions on that one? And then number 7. Y is less than or equal to -4 should have been a horizontal line at -4, solid shaded below. And then any of the points leading up to the line would have been a solution. Questions on that one? Alright. Move on to the next page. So a lot of this information is the same. Making sure that you find the slope and y-intercept, that it's about the different types of lines, the different types of shading. But now instead of graphing it, we are going back and writing the inequality for these graphs. These solid ones are easier to do. And if you've already done this, it's great. You can check yourself after we get these. The dashed lines are a little bit more challenging. So with these, I would find what you know to be true immediately. So like, I know this would be my y-intercept. Be careful because it is a little blurry, but this should be 8, not 6. Finding your slope, it needs to be consistent. So maybe you aren't sure because parts of the line are missing. Start looking for points that fall on the graph or on the grid lines exactly. So maybe I find this point and that's the first point I see. Well, if I was looking for this slope, this would be 1, 2, 3, 4 over 2, -4 over 2. That can be simplified to -2 over 2. And I would need to make sure this follows all the way through. So if I keep going down 2 to the right one, and then up 2 to the right one, the shading is not going past that, so I can say that is my slope, -2. So we know this much. It is a dashed line, so it has to be greater than or less than, strictly greater than, strictly less than. From the y-intercept, is it shaded above or below it? Above, so this would be greater than. So y is greater than negative 2x plus 8 would be our answer.
Wait, hold on. Ow.
Which part?
Never mind, I got it.
For number 2, it's really easy to see what our y-intercept is at negative 4. Here, I can easily see what my slope is going to be of 1 over 1. And then this would be shaded above or below? Below. I know it's a solid line, so it has to be less than or equal to. So y is less than or equal to x minus 4 would be our inequality. Erica, did you have a question? You're in line after Olivia. So we're going to go over 2 more problems, then I'll bring it back. Do we have any questions on these 2? On the back, we're just going to do a few more. For number 3, again, we have a solid line, so it's easier to see. Yours may not be because it didn't print in color, but this is where it's shaded. So make sure that you know that. What would our y-intercept of 3 be? 4. And then what would our slope be? Negative 3 over 1, or just negative 3. And then from our y-intercept, is it shaded above or below? Above. And it has to be greater than or equal to because it's a solid line. So y is greater than or equal to negative 3x plus 4. Yes. You mean a solution. Moving to 5 and 6. For number 5, would this be an X or a Y? You guys have a bad habit of starting to pack up way too early. Stop that. It's an X. It's an X. This is at 6. Would this be greater than or less than 6? Greater than. And if you're not sure, pick some of the numbers. Is 10 greater than 6? Yes. For 6, this would be an X or a Y? Y. This is at negative 9.
How are you doing this?
This has to be an equal to, is it less than or greater than?
Less than.
And then or equal to. Take 3 to 5 minutes to do the others. Kayla, ask you Yes. Take another 3 to 5 minutes to do the remaining